In this video, we're going to start talking about modular arithmetic. So a modulo M system, or mod M, is a mathematical system of M elements 0 through M minus 1. So for instance, modulo 6 contains the elements 0 through 5, and modulo 10 consists of the elements 0 through 9. All right, so I want to determine what the number of sum, difference, or product is congruent to in mod 8. So there's a picture of a modulo 8 clock drawn below. All right, let's start with 3 plus 7. So if I do 3 plus 7, I would start at 3 and I would go clockwise and add 7. 1, 2, 3, 4, 5, 6, and 7. So in our case, 3 plus 7 is equal to 2. All right, now let's take a look at 2 minus 8. Here I would start with 2, but because I'm subtracting, I'll go counterclockwise by 8. So 1, 2, 3, 4, 5, 6, 7, and I'm back to 2. So 2 minus 8 is equal to 2. But let's take a look at this in like a base 10 type of situation. We know in our number system 3 plus 7 is equal to 10, but clearly you can see 10 is not on this clock. So in order for me to get back to where I started, I would need to go 8 spots like we just did. So I can take 10 and divide by 8. Well, 8 goes into 10 one time with a remainder of 2. Notice the remainder matches up with what my answer is going to be. Now, let's take a look at 2 minus 8 in our number system. We know 2 minus 8 is negative 6. Well, clearly negative 6 is not on this clock. Again, I would need to be able to add 8 to get back to its original position on a modulo 8 clock. If I take negative 6 and add 8, my answer is 2. Notice that's exactly what my answer is going to be here. All right, one other example with the mod 8 clock. Let's do 5 times 4. Well, if I want to do 5 times 4, I would start at 0, and I would need to do 5 groups of 4. So here's the first 4. The second 4 gets me back to 0. The third gets me to 4. The fourth gets me back to 0. And the fifth group of 4 puts me at 4. Now again, I want to do this in our number system. 5 times 4 is 20. 20 divided by 8 is 2 with a remainder of 4. Notice again, the remainder is exactly our answer. So in general, the remainder is the answer to a modulo problem. Not how many times I revolve, but the remainder. Okay, so in general, if the number is bigger than the possible values in modulo M, then we can take the number and divide it by the modulo number. The remainder is your answer. In general, if the number is smaller than the possible values in modulo M, then take the number and continue to add the modulo number until the answer is somewhere in the modulo. So let's take a look at an example of each. I want to be able to determine the modulo class to which each number belongs for the indicated modulo system. So in mod 5, that's going to be what? 0, 1, 2, 3, and 4. So my answer's got to be one of those 5 numbers. Well, clearly 54 is too big. So what do? 54 divided by 5, because we're in mod 5. 5 goes into 54 10 times with a remainder of 4. So 54 mod 5 is congruent to 4 mod 5. So in other words, our answer here would be 4. Okay, now let's take a look at negative 24 mod 4. In mod 4, my options are either 0, 1, 2, or 3. So clearly negative 24 is not in mod 4. So what am I going to do? I'm going to continue to add the mod, which is 4. Negative 24 plus 4 is negative 20, still too small. Negative 20 plus 4, negative 16, doesn't work. Add another 4, nope. Add another 4, nope. Add another 4, still doesn't work. And finally, when I add it again, I get 0. So in general then, negative 24 mod 4 is congruent to 0 mod 4. So A is congruent to B modulo M if A and B have the same exact values. So that's what we're looking at for this. Okay, for the next major part now, we're going to solve mod equations for this. So I wanted to be able to determine all positive number replacements for the blank to make the statement true. So I want to figure out what 5 plus 6 is in mod 7. Now remember, mod 7, that contains 0 through 6. So my final answer's got to be one of these values. Well, I'm going to take 5 plus 6, because we know that's 11. Clearly 11 is not in mod 7. So what am I going to do? I'm going to take 11, divide it by 7, that's 1, with a remainder of 4. So in general then, 5 plus 6 is congruent to 4 mod 7. Now, this one was a little bit easier because I can simplify the left-hand side. For the next set of problems, a lot of what I'm going to do is going to guess and check to see what works. And what am I talking about? Well, let's take a look at the next example. I want to fill in the blank that makes that congruent. So again, mod 6 is going to be 0 through 5. And all I'm going to do is I'm going to try each number to see if it makes it a congruent statement. Let me start with 0. 4 plus 0 is 4, and that is not congruent because 4 does not equal 3. So let's go to 1. 4 plus 1 is 5, but 5 is not equal to 3, so that doesn't work. So we're going to go to 2. 4 plus 2. Now that's 6. Now the problem is 6 is not in mod 6. So I would take 6 divided by 6. That's 1 with a remainder of 0. So that's the same thing as 0 here. And that doesn't match. So now let's go to 3. Well, 4 plus 3. That's going to be 7. Of course, 7's not in mod 6. 7 divided by 6, that's 1 with a remainder of 1. That doesn't match. Let's go to 4. 4 plus 4 is 8. 8 divided by 6 is 1 with a remainder of 2. Remember, the remainder is what I care about. That doesn't match. And the last one is going to be 5. 4 plus 5 is 9. 9 divided by 6 is 1 with a remainder of 3. So 3 does equal 3. We found our answer. So how would I write this at the end? 4 plus 5 is congruent to 3 mod 6. Okay, let's take a look at the next example then. So now we're going to start with doing some of the subtraction problems for this. So it's mod 8. So the only values in mod 8 are going to be 0 through 7. Okay. All right, let's start with 0. So 0 minus 5. Well, 0 minus 5, that's negative 5. Problem is negative 5 is not there, so I would add 8. That's going to be 3, and that is not equal to the 4, so 0 doesn't work. So let's try 1. That is going to be negative 4. Again, that's not in mod 8, so I would take negative 4 plus 8. That is 4, and 4 does equal 4. So this will work. Now, keep in mind, notice what I have here. For the addition and subtraction problems, you will have exactly one answer. That's not the case for the multiplication, but it is for addition and subtraction. So I'll stop there, and we know there's only going to be one answer. So my answer here is 1 minus 5 is congruent to 4 mod 8. Okay, let's take a look at the next example. So 6 minus blank is congruent to 8 mod 9. Now, we should be able to identify very quickly, for instance, 6 minus 0 is 6. That's not going to work. 6 minus 1 is 5. That's not going to work. 6 minus 2, which is 4, not going to work. 6 minus 3 is 3, that's not going to work. 6 minus 4 is 2, that's not going to work. 6 minus 5 is 1, that's not going to work. 6 minus 6 is 0, is not going to work. Now remember, with mod 9, we've already taken care of a majority of the issue. That's going to be 0 through 8. So the only other options I have left are going to be 7 and 8. So let's take a look at 7 first. 6 minus 7, that is negative 1. The problem is negative 1 is not in mod 9, so what do? I add 9. Negative 1 plus 9 is 8, and 8 does equal 8. We did find our solution here. So what would you write? 6 minus 7 is congruent to 8 mod 9.